Um, Hello everyone. I am Prasanth. Today we will be talking about the standardizing the unstandardized, which is securing AI supply chain with Model-Spec and Kitops. So let's start. So if you are not comfortable with English or do you need translation, you can scan this QR code to basically get translated with the captions for Korean language or any other language that you are comfortable with. So you can follow this talk pretty good. And in the world, we are seeing there is a lot of prompt injections, which is happening in the AI browsers, and there is a lot of problems with the supply chain attacks, which is being rising, and there is a possibility of models getting poisoned with just like 500 to 600 data points, and irrelevant of the size of the model, these LLMs can get pretty poisoned and have a lot of issues. So we know that your every pipeline works until it doesn't. So let's start with something pretty simple, like a story where all the AI ML projects start, which is from the data set. For every AI ML project, it will collect all the data sets and then clean the data, mark it up, label it, and do all the things with the data. Then you're gonna write the code for the data for creating the ML model. Then you will either write a code with PyTorch framework or any other framework, or you can use notebooks to do that. And you will track these changes in possibly Git, or even some companies do track this in DVC or something. So you can do that. So DVC is data version control, which uses MD5 sums to map your data sets to your ML code. So it's kind of a versioning thing. And after this training, you will get a ML model. And this ML model involves creating an API development, so users can actually consume your model, not just the data scientists. And the next thing is testing and validating the models. After that, you're going to deploy those models into production, either with tools like Kserver, or there is a plethora of tools in the AI ecosystem. So we're going to use this lot of tools and things. So this will create an end-to-end pipeline, basically. So even people would use Kubeflow, or which is a tool which contains basically all of these things, but in its own kind of a version. Whereas there is also another tool called MLflow, which is kind of the same but also different. And everything goes good until everything comes to a breaking point where you have some model in your production environment and it is producing a biased results, which it should not, and the inference is completely wrong. When you tested it out, you check the logs, you check the metrics, everything seems good, but the model seems to be underperforming, and you don't know why, because possibly a model got poisoned or model got wrong data as a input, so garbage in, garbage out, so your model doesn't work great. So what are the causes? What is going wrong? So it's basically there is no immutability in these kind of tools. So everything is tracked, versioned, and everything is in Git or DVC, which these tools are possible to be force pushed, which means there's literally no security scanning, no history, no lineage. It's very hard to roll back because all these data sets are pointed in S3 buckets or Azure, whichever you use. It's kind of a tough. And also what code you used to train this model is also tough. In this multi-dimensional AI thing, there is no a traditional softwares have a single flow, where in AI you need to have multiple things. You need to maintain the correct version of the data set, you need to maintain the correct version of the code, you need to maintain the hyperparameters, you need to maintain the weights. There is a lot more thing when it comes to AI development. So also, this question, what version is your AI model you're using is running in production? And these critical questions, companies or people who deploy AI models doesn't have clear answers because they themselves doesn't know what exactly runs in the production. They have kind of an guessing work, but there is no literally a standard way of doing it. So, and basically MD5 hashes, like if you know DVC uses MD5 hash to actually correlate your data set to your ML code, which is kind of crazy. And yeah, bit about me. I am one of the contributors of Go Harbor. It's a open source container registry under CNCF. I do a lot of contributions to CNCF projects and CNCF ecosystem, and I am pretty much interested in this Kitops and Model-Spec. So which is, we're gonna see all these problems I stated and how using Model-Spec and containerizing your AI models can solve the issues. So to know more about me, you can scan the QR, and there is also even more problems. There can be CVEs in ML model dependencies, and there can be code injection through those vulnerabilities that can happen. And there is also this common LLM risks, which you can like go to the OWASP page and you can find what are the common LLM risks that includes. And there is a real need for versioning in ML ecosystem because you can't just mark a thing with MD5 hash and then call it as a content addressable storage unless you have something at least SHA-256 or anything that is cryptographically verifiable, like, yeah. And these immutable versions need to have semantic tags for us humans and digest for machines. And MD5, please don't do that. Probably you also need to have cryptographic signatures, tamper-proof attestations, and human verification on the pipelines, signing, etc. And there is also, you need to have clear lineage, which is basically provenance of the model, where it comes from and where it goes, like entire pipeline. And so as I said, the projects is Model-Spec. Model-Spec is the specification written by a cloud native AI. So this spec is based on the OCI spec. Most people who work with containers know about OCI spec. OCI spec is the one spec which, if you are using Docker or any other containers, you would literally use underneath the hood. And this tool, Kitops is a standard tool which looks more like a Docker, and it gives the developers the ability to implement these Model-Spec and then package your models into containers and stuff. Yeah, so containerizing your model, so you can achieve versioning, sharing, deployment. And the good thing is, you don't need, if you are using Kubeflow or MLflow or any other end-to-end pipeline tools, you're going to be stuck with their own registry. Like Kubeflow has its own registry, and MLflow and all of these other open source tools have their own registry, and you're going to be stuck with that registry, and data migration would be a pain point in that. But if you're using like containerizing your AI models, you can basically deploy it in the container registry, like something like Harbor or something like Artifactory or something like Quay. These container registry which you already might have using in the real world scenarios. So, and these are like reproducible, auditable, because containers you can, that is already tested and fully verified. And you can also do the signing part and also generate SBOMs for your AI models. And there is a lot more going on. Let's take a deeper look on how Kitops and Model-Spec solves this problem. So in Kitops, basically you get a kit file. Kit file is nothing but a Docker file, if you know of Docker. So it's basically you telling the Kitops tool that my model is this, and my model is a TensorFlow model. My model has these annotations. My model has these data sets. My model has these notebooks. My model will need to have this training. My model, like all this metadata thing that you need to put it in your model. So you would give all this data into this kit file, which is a YAML file, similar to Docker file. And once you have that, like you told the Kitops tool, like this is the model I am going to run. And then you will have these commands like package. Now kitpack will package your AI model into a OCI container, which you can directly ship into any other container registry that you are already using. There is no need for getting into another subscription for just storing your AI models where you already have container registries in place. So you can just git pack and git push your models to the container registry, and you can either git pull or unpack to deploy your models into production. It also works with tools like Kserve. They can pull these containers and then deploy your model into Kubernetes or things like that. And for more commands and reference, you can check out this link. And okay, next the question is, how do you manage versions? Like, this is a multi-dimensional problem. We don't have a single code that is tracked on Git, and we are going to manage the versions. No, we have a lot more going on, because we have a data set, we have a parameter tuning, we have a config, we have an environment which we train the model. So all these have an impact on the ML model accuracy and the ML model things. So Kitops solves this by packaging everything into a model kit. So a model kit will contain your model, your parameters, your data set, your code, your metadata, everything. So, and the good thing is you can cross-reference this across different models. Like if you have version 1 to 2, you can like take only the things that have changed from version 1 to 2. So you don't track the same thing again and again, exploding your S3 storage things. So yeah. And then you can sign your models like your container images, publish signatures, and you can do a lot more authenticity, integrity, provenance, and all these things that comes with containers by default. You get those too. And yeah. And then there is SBOMs, which you can like create SBOMs from the Git files, which is good for reproducible AI systems. And yeah. And these are the links you can go through to check out like what are the Model-Spec and the tools you need to have. And this, please scan this QR code if you want the slides, so you can go through the links and stuff. There is also a feedback form. You can like, if you like the session or not, please let me know so I can improve the upcoming sessions. And thank you all for your time, and thank you for the opportunity to present here in OpenSSF Community Day, Korea. Thank you.